the foundation of what, like basically what a matrix is where we start. A matrix is defined as a rectangular array of numbers with m number of rows and n number of columns. It looks like this. So these brackets obviously go on the outside, and then there's a series of numbers in columns and rows inside. The first thing you're going to learn is what the dimensions of the matrix are. So kind of like a piece of wood is 2 by 4 because that's 2 inches by 4 inches, or close enough. So that's not exact, but close enough to it. The dimensions of a matrix are the number of rows, and then the little x, like by, the number of columns. So if I were to read the order of this matrix or the dimensions of this matrix, it would be 3 rows and 2 columns. And the order is important there. So again, rows that go across, columns that go up and down. If you think of like the columns that hold up a house, right, they would go up and down. So that's just the foundation, okay? But it is super important because you're going to see it moving forward. So they will either say what's the order of the matrix or what are the dimensions of the matrix, and that's what it means, the number of rows and the number of columns. There are, when we're going to use these matrices to solve equations, there are 3 things that you can do with a matrix. You can interchange rows, so you can literally switch rows. I could switch row 1 with row 2 with row 3, row 1 with row 3. It doesn't matter. It's not going to change the value there. I can multiply a row by a non-zero constant. So I can multiply everything in a row by a single number or a negative. And I can either add 2 rows or add the multiples of 2 rows. These notations are going to be important because you're going to start to use notation to describe to me what you're doing with the matrix. So if I had the matrix 1, 2, 3, 4, 5, 6, let's say I just start there. And I wanted to switch row 1 and row 2. This would be my row 1, this would be my row 2. Then it would look like this, R1, double-sided arrow, R2. And the result of that would be 4, 5, 6, 1, 2, 3. So that's the first thing that you could do with a matrix. The second thing is you can multiply any row by a non-zero. So we can't multiply by 0, but we can multiply by anything other. We can multiply by a positive number, a negative number, a fraction. So let's say I wanted to take this new one, and I wanted to do 2 times R2. That means I would then multiply everything in row 2 by 2. So the first row would stay the same. The second row would become 2, 4, and 6. So if I said 2, row 2, I'm going to take this last matrix that I just made and multiply everything in row 2 by 2. So 1 gets like you're distributing it. 2, let's multiply by 1, 2 times 2, and 2 times 3.
So you can multiply the different rows by different numbers.
Correct. And then the third thing is you can either choose to add 2 rows or you can add a multiple of a row. So if I had said I want to add row 1 and row 2, then I would literally be adding these 2 and I would get 6, 9, 12. When you add 2 rows, you can replace either of those rows with the sum. So if I wanted to add these 2 and replace row 1 with them, then my new matrix would look like this. I added 2 rows and I replaced the top. You could also add those same 2 rows and replace the bottom. You can't replace both, but you can choose which one you replace. You can also multiply 1 row or both rows by a number and then add. So that's the baby step that we're getting into. The goal is to eventually solve, this is a system, you don't know it yet, but this is a system. And we're going to use the system, we're going to use the matrices to solve the system. So we're going to use matrices to solve the system. So if I were to say, I'm just going to pick, but I'll explain why later. Multiply row 2 by negative 3 and add it to row 1. Then this means take row 2, multiply it by negative 3. I'd get negative 6, negative 12, negative 18. Add it to row 1, 6, 9, 12, and I end up with 0, negative 3, negative 6. And then I can take and replace either of my rows with this new row. So I can leave the first row and I can replace the bottom row with it. So there is a reason why we would want to do this, and that's to solve the system, which basically the instructions are on the next page. But one of the instructions are going to say, perform row operations to get an end result. And these are the three things you can do. So you can either switch rows, you can multiply a row by a non-zero constant, you can add or multiply and add together in one. This is why. So you can solve a system using a method called the Gauss-Jordan method. So I'm not going to test you on the name, but if you ever see that name, that's what this is. But the goal with Gauss-Jordan is to rewrite your system in matrix form. So I'm going to take something like 2x minus 3y equals 6, 4x plus 2y equals 8, and I'm going to rewrite it in matrix form, which means get rid of all the variables. It's 2, negative 3, 6, so coefficient on the x, coefficient on the y, and then the constant. And rewrite the bottom row, 4, 2, 8. So that is the matrix form of that system. Then you're going to perform row operations to get the matrix to have this format. So the goal at the end is to end up with a 1, a 0, a 0, a 1, and then these will be numbers. And then 3 is take that matrix and put it back into equation format to get your x and your y. So if you think about it, if this said 1, 0, 3 and 0, 1, 4, and I wanted to put this back into equation format, the last column is always your constants. This is your x and this is your y. So if it's 1x and 0y equals 3, that's the same thing as saying x equals 3. And if it's 0x plus 1y equals 4, that's like saying y equals 4. So once you get it into this format where there's a 1, 0, 0, 1, and then numbers in the last column, the top row is your x equals, the bottom row is your y equals, and you have solved this system. There are two special cases. If all zeros are left in one row, it's all real numbers, so you've canceled everything out. Think about like if we did it with substitution or elimination, you canceled everything out and 0 equals 0. That's a true statement. That's all real numbers. And if you have 0, 0, but the number left is not 0, then it's no solution. So if one of your rows said 0, 0, 1, then it's no solution. It's like I'm speaking a different language today, right? I mean, yeah, just wait. I promise you it will get more familiar, but no. Yeah, you're going to get it. You've seen matrices? Yeah, so I think you've seen matrices in tomorrow's lesson on SAT, adding, subtracting, that kind of stuff. They probably would not have you solve a system using, because let's face it, if I gave you that system and I said solve it, are you going to choose this method?
So do we have to show it on the test?
For today, you have to do it, yeah. And then on the quiz on this, you have to do it, yeah. But like on a standardized test, they don't know which method you use to do it, so they're never going to tell you to solve a system using this, right? But the stuff in 10.2, I think, is what's on there. All right, you ready?
No.
Yes. First step, rewrite it in matrix form. What's row 1? 1, 2, 5. Row 2? 2, 1, negative 2. Okay. Now, I'm going to suggest a pattern. It doesn't always work, but a lot of times it works. Okay? The pattern I suggest is if you can get a 1 in this top spot to start with, which is already there for this one, that's the easiest way to move forward. Okay? If you can't and it gives you a fraction, then that's why I would say don't do that. Okay? But if you can get that there, then do it. So if it's not a 1, but there's a 1 in row 2, I would switch the rows. If there's not a 1 in that first spot, it's like a 2, I would multiply by a half. See if all my numbers at the top are even, and then get the 1, okay? But if I'm going to get fractions in the meantime, I'm going to wait. Because the next step I would say to do is get a 0 where that spot is. So I work my way down, okay? So if I want to cancel out a 2, what do I have to make what I added to? -2. Is there a way to change row 1 so that that first spot's a -2? Multiply by -2. So my notation is going to be -2. I wrote -r. -2 row 1 plus row 2.
We have to show these annotations on the test.
And these are not so bad, but we're going to get to a 3 variable one.
Oh, it's a good word.
And it's not that no one ever gets it right on the first time, but people tend to make mistakes through the way. They're usually involving a negative,
I was
okay?
trying last year to watch out for the fourth quarter, the last 3 weeks of school, because you're like actually like really confused in this class.
So last year, 3 weeks, they didn't do this last year.
Oh,
So maybe that's something else we're looking forward to. Maybe that's next chapter? Series and sequence? Yeah.
where's these?
Different? Yeah.
So
This is the most complicated, and this is 2 variable. We're about to get a 3 variable. 3 variable, gosh, Jordan, is like one of the most complicated process. It's the same thing over and over again, but it's tedious. And if you get a negative in there and you screw it up, your goal is to go back, look at your own annotations, figure out what you did, and see where you went wrong.
so who's got your mic in it?
I don't know. All right, so we're going to do what we just wrote. -2, row 1 plus row 2. So I'm going to multiply -2 to the 1. I get -2. -2 to the 2, -4. -2 to the 5, -10. And then I'm going to add it to row 2. 2, 1, -2. Add them. I get 0, -3, -12. Now I can replace, because I involved row 1 and row 2 in that addition, I could choose to either replace row 1 or row 2. But I was trying to get the 0 here, which means I'm going to keep the original row 1, 1, 2, 5, and I'm going to keep this one as my new row 2, 0, -3, -12.
So if you combine them, you can put the new equation
In either spot. Yep, you just can't do both. Yep,
So this is just a new method to solving.
Yep. The most fun method you could ever possibly imagine.
Mr. Soldier,
Yeah.
if there wasn't a 1, we should top left, or would you do the next?
So if it was, let's say it was a 3 here, you'd have to multiply both rows. I'd have to do the top by -2, the bottom by 3 to get them to cancel. So the goal is still for them to be the same number, 1 positive, 1 negative.
So this is like as if if we're doing like a squishy-
With the X and the Y.
have a Z and then
Exactly.
letter solve for each.
Yep. Okay, so now I go and I want to get a 0 or a 1 here and a 0 here, okay? And the order there doesn't really matter, okay? If it was easy to get this 0 by changing one row and adding it, maybe I would do that. But in this scenario, I'd have to multiply the top by 3 and the bottom by 2 to get them to cancel. The other thing I can do is make a 1 in that spot. So the way we get a 1 in a row after we have the 0 is to multiply by the reciprocal. So what's the reciprocal of -3? -1/3, right? So I multiply by -1/3. My top row stays the same. 1, 2, 5. Bottom row becomes 0, 1, 4. So now my bottom row is done. Yep. Yep. Now I need a 0 where the 2 is. How do I cancel out that 2 with a multiple of 1? Good. -2, row 2 plus row 1. So -2, this is 0. -2, -8, and then 1, 2, 5. Add them, and I get 1, 0, -3. And that's going to replace the top row. And from the top row, I get x equals -3. And from the bottom row, I get y equals 4. Everybody's still breathing, right? All right. So first step, Rewrite it in matrix form. What's my first row?
2 minus 3, 10.
Second row. Okay, so remember I said if you can easily get a 1 here, start with that. My options would be, at this point, to multiply everything by a half, right? Because multiplying by the reciprocal gets 1. But then I end up with 3 over 2. And I would avoid the fractions as long as you possibly can. So the other option is to go straight for the 0. How do I get a 0 there? Multiply either one by -1 and then add it, right? It does not matter which one. So let's say I said -1, row 1 plus row 2. So -1 gets multiplied by row 1. -2, +3, -10, plus row 2, 2, 2, 5. And you get 0, 5, -5. We can replace row 1 or row 2, but we want the 0 in row 2. So we're doing 2, -3, 10, 0, 5, -5. Because I used, this was row 1 and this is row 2. Because I used both, you could replace either. But I wanted the 0 here. So I want to replace row 2. So I kept row 1 the same and I replaced row 2.
Why couldn't you, like, does the order matter? Because if you did it for the other one, it would be 0, -5, and 5. And then it would give you.
But then you have the 0 at the top and you want the 0 at the bottom. Does that make sense?
No. What I mean
Oh.
is, like, when you multiply.
Oh, no, because that's not a 1 yet. When you get that to be a 1, your answer would be the same. So, like, I need a 1 here now, right? So I'm going to multiply by a 5th. So top row stays the same. Bottom row becomes 0, 1, -1. If you did it the other way, this was a -5, right? And this was a +5. You'd multiply by -1/5 because you still want a +1. So you get a +1 here, but then you get a -1 there. So you end up with the same bottom row. Your ending matrix has to be the same. Yep. Yeah, when you're doing a reciprocal, that's totally fine. Okay, so now I got my bottom row first this time, okay? So I'm going to work my way up, and I'm going to get the 0 here. How do I make that a 0? +3, right? +3, row 2 plus row 1. I get 0, 3, -3, 2, -3, 10. I get 2, 0, 7. My first row, 2, 0, 7. Second row, 0, 1, -1. I've got my zeros. I've got 1, 1, but I have 1, 1 left to get. So after I get the 0, I get that 1 by doing what? Multiply by the reciprocal, which in this case is a half. So a half times 2 is 1, 0, 7 halves, 0, 1, -1. So my answer is 7 halves, -1. All right. Oh, this should be equal 0. Oh, man. Equals 0. Yeah. All right, so first of all, what do you notice after I put the 0 on there? But what do you notice that's different with this one than the last one? The constants on the left-hand side. So the first thing, and you could move it and then rewrite it, or you could just like, okay, I know this is coming over as 10 and this is coming over as 15. That's fine. And then when you rewrite it, it's 2, -5. Just make sure it's a positive 10. 3, 1, positive 15. So you have to move the constant to the other side before you can put it into matrix form. Okay. So now, my goal originally was to get a 1 here or a 0 here. Give me one way to do one of those. To do what? Oh, you're getting a 0 here. Okay. Give me another, we'll do that one. Give me another way. So if I want to get this 0, I can multiply the top by -3, bottom by 2. Yep. How about if you want to get a 1 here? Is there a way to do that? I can multiply everything by a half, but I'll have a fraction, but I could do that. Anything else?
Multiply the bottom by -1.
So I would do the other way around. I would do 2 times -1 and then add them, but you definitely could do that. All of those steps are good to start with. You could literally do any of those steps, okay? So I'm going to go with the first one just because it was the first one, but you literally could do any of those steps. So if I want a 0 where that -5 is, I can multiply row 2 by 5 and then add it. So I'm doing 5 row 2 plus row 1. Yeah.
What would the row switch be useful in?
If you had a 1 where the 3 was, I would switch it. Yep. So this is 15, 5, and 75, 2, -5, 10. And I get 17, 0, 85. That replaces row 1.
Isn't it a -10 at the top?
Is it? No, we moved it to the other side. So when you have to move it first. And then it's 3, 1, 15. So now before I go to multiply a 17 and a 3, I would see if I can get rid of that 17 by multiplying it by its reciprocal. So does 17 go into 85?
Yes.
What do we think? 5 times?
Yeah.
5 times, okay? They should not be like 85 over 7. Like 85 over 13 is not going to be an answer, okay? When we get to the big ones, we tried to keep them all to be whole numbers even. But it shouldn't be nasty numbers. So I would get rid of that 17 and 85 now. So I'm going to multiply everything by 1/17. And I get 1, 0, 5, 3, 1, 15. So I almost have everything I want. I have the 1, I have the 0, I have the 1 on the bottom, but I need to make this 3 a 0. How do I do it? Good. -3, row 1 plus row 2. -3, 0, -15, 3, 1, 15. 0, 1, 0. And that replaced row 2. So 1, 0, 5, 0, 1, 0. And from here, my answer is 5, 0. So you can totally have a 0 in that last column. It doesn't mean it's no solution. It means as long as you have a 1 in either the x or the y place, it means that variable is 0. Yeah.
So what would no solution or
It would be, no solution would be a whole row of zeros. No, sorry. All numbers would be a whole row of zeros. And no solution would be a 0, 0, and then a number. So it's like having no variables equals a number. That's a no solution. All right, last one before we really get into the fun.
How fun.
Oh, you have no idea. All right, rewrite first row. Actually, you try. You could do it. I have faith. All right, so row 1, 3, -2, 1, row 2, 6. Thanks, you too. -4, -1. Okay, somebody give me what they did next. So row 1, -2, and add them to get the 0, yeah? -2, row 1 plus row 2. -6, +4, -2 plus 6, -4, -1, and you get 0, 0, -3. What did we just say happens? No solution. It doesn't matter. As soon as you get it, either row, any point along the way. Yep.
Wait, as soon as you get what? 2
As soon as you get 2 zeros and a number, it's no solution. Or all 3 zeros, it's all real numbers. No matter what step you did to get there, that's it. Yes. If it was all 3 zeros, it's all real numbers. Yep. All right, ready? Deep breath. 3 variables. So what happens when it's 3 variables is just more work, okay? But the logic is the same. So if it's 3 variables, it becomes 4 columns because it'd be a column that is X, a column that is Y, a column that is Z, and then the constants are in the last row. The pattern you're trying to get is basically just an expanded form of what you just got. You have a diagonal of ones here and then zeros above and below. So it's 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the last column is going to be a combination of numbers. For these, again, I'll recommend a pattern, but it doesn't always have to stick that way. But like in teaching this with pre-cal the last couple of years, they would rather try for a pattern than to just look at it and try to figure it out on their own. So I'm going to suggest a pattern. It works a lot of the time. It may not work all of the time, okay? So the pattern for these is I start, if I can get a 1 in that top spot, because it makes everything after it easier. If it's going to bring fractions in early on, I avoid it. These questions should be whole numbers, so you should be able to avoid your fractions almost at all costs, okay? It's not like if you just Google 3 variable systems of equation and you try to do any example you find, it's not going to have a fraction. But specifically, the ones we picked out don't, okay? So I try to get a 1 there. Then I work my way down. So I go to this 0. If I have a 1 here, I can always multiply that row by the opposite of what I'm trying to get and then add them. Then I get a 0 here. And if I've done the 1 in the top, all I have to do is make this the opposite of whatever variables or values there, and it will give me that 0. Then I go to the 0 to the right, so I make like an L. To get that, I can either combine it with this one or this one, because that's what will be there if I haven't gotten the other zeros. So that one's like the one that there's more than one way to do it. After I get that, I go for the 1 because this should be a whole number, so I'd be able to multiply by the reciprocal to get it to that one. And then I work my way up and over. If this is a 1, then it's easy to get that 0 because I'd multiply the bottom by the opposite of what's there. And then this 0, same thing. I multiply the 1 by the opposite of what's there to cancel that out. And then the last 0 comes by multiplying. This is the only thing left that's not 0 that I can change to cancel out. So if you follow that pattern, it's not like you're trying to figure out what to do. It's a fixed row you're going to add each time in a fixed pattern, okay? So we're going to do these both with that pattern. And I'm telling you right now, if you don't practice this and you try to wing this later, it's going to hurt. So make sure you're practicing these. All right, step 1, the easy step. Rewrite your rows in matrix form. So what's row 1? 1, 3, -6, 7. Row 2, 2, -1, 1, 1. Row 3, 1, 2, 2, -1. All right, so step 1 is already done for us. There is a 1 in this top column. In the top row, top column. If by chance, like let's say that these 2 rows were switched and a 2 was in that spot, I would switch them. So if the 2 was in the top row, I would switch row 1 and row 2 or row 1 with row 3. Doesn't matter which one you grab. You just want a 1 there, okay? But that's already done for us. So then the next step is I want a 0 where the 2 is. How do I get that? -2, I could either multiply it times row 1 or row 2. Or row 3, but I'm going to do row 1. So -2 times 1 is -2, times 3 is -6, times 12 is +12, times 7 is -14, and I add it to row 2. 2, -1, 1, 1. 0, -7, 13, -13. Now, because I use row 1 and row 2, I can replace either of those rows with it, but I wanted row 1 to have the 1 there, so I'm going to keep row 1, and I'm replacing row 2 with what we just got. All right, 1, 2, 2, -1. All right, then I want to work down again. I want to get a 0 where the 1 on the bottom is. So if you follow the pattern, you're now fixed as to what you can do next. There's nothing I can change 0 by to make it be 1, because I can't add to a row. So I can't I can't subtract 1 from here to make it cancel out. And there's nothing I can multiply 0 by to get it to be 1, which means I have to use row 1 to cancel out that 0. So how do I change row 1 so it cancels with the bottom row? Multiply by -1. So -1, row 1 plus row 3. So -1, -3, +6, -7, plus 1, 2, 2, -1. 0, -1, 8, -8. And that replaces row 3. 1, 3, -6, 7, 0, -7, 13, -13, 0, -1, 8, -8. Now I want a 0 where the -1 is. If I try to use row 1 and row 3, like let's say I multiply this by a +3 and I add the rows, this is going to give me a 0, but I'm going to lose this 0 because this is going to end up being 1. So for this 0, you have to use row 2. So it limits your possibilities, which I think makes it easier because you don't have to try to figure out what to do next. When you get this 0, what was that, -1? When you get this 0, you have to use row 2. So how do I cancel out, how do I get a 0 in the bottom? 7 times row 3 plus row 2. -7 times row 3 plus row 2. So 0, 7, -56, +56 gets added to 0. -7, 13, -13. And that replaces row 3. Now before I replace it, what am I trying to get in this spot? How do I get that? What's the reciprocal of -43? 1 over -43. So I'm just going to do that in one step. So that becomes the bottom row. 0, 0, 1, -1.
Wouldn't it be no solution at that point?
Because this is 3. It has to be 3 zeros. Yep. 0, -7, 13, -13. 1, 3, -6, 7. All right, so my bottom row is done. And what is Z? -1. If that's not a whole number, you did something wrong. So now I want to get a 0 where the 13 is. Yep. To get that 0, I have to use row 3. If I use row 1, I lose the 0 on the front. So what can I multiply row 3 by to cancel it with +13? -13. And I get 0, -7, 0, 0. Now, before I replace that row, what I want the -7 to be? A 1. How do I make it a 1? -1/7. So that's my middle row. 0, 1, 0, 0. Top row is still 1, 3, -6, 7. Bottom row, 0, 0, 1, -1.
Will they always cancel like that? Like the 13, 13?
Yeah, if you put the 1 in the bottom first, yeah. That's why I do that pattern. So it doesn't mean you have to do that pattern, but I think the pattern makes it easier.
So the pattern is start at the top left.
Down, over, get the 1, work your way back up.
That's how it always works.
Yeah. All right, now I go here. I want a 0 where the -6 is. I would say this one, it doesn't matter if I do that 0 or this 0 first. Those two zeros don't matter which one you get first because it's the same thing. You're either, to get this one, you have to use row 3. To get this one, you have to use row 2. So the order in which you get those zeros does not matter. But because I like a pattern, I usually work that one first. So I usually go back up. So to cancel out the -6, I have to do what? row 3 times 6 plus row 1. So 0, 0, 6, negative 6, plus row 1, 1, 3, negative 6, 7, 1, 3, 0, 1, and that replaces row 1.
If we were the thing every time.
Yeah. So the last 0 is where the 3 is, and I get it how? Negative 3. Row 2 plus row 1. 0, negative 3, 0, 0, 1, 3, 0, 1, 1, 0, 0, 1. So what's the answer to this system?